we have seen photodiode. Its symbol, and the photodiode is reverse biased. When it is reverse biased, the light reverse biased, very small current will flow. That current, whatever is flowing, is said to be the dark current. So in the characteristics I have shown dark current, and this dark current should be as less as possible. If this dark current is more, when the light is illuminated on the PN junction diode, then it will act as the error noise. Okay, it will act as a noise. So that is the reason, you have to make sure that the dark current is very less. Okay, then what we are doing after that, we are eliminating it with light. So when you are eliminating it with light, so the the charge carriers will be one second. Okay, the charge carriers will be generated here in the junction, and this electrons will get attracted towards the positive terminal, and this holes are attracted towards the negative terminal. So because of that, the current will start flowing. So here, compared to the when there is no light illuminated, the current is more. Okay, like that, as you increase the intensity of light, the current through the device will be more. So that's why the characteristics are like this. Okay, so here this is all related to the photodiode. Okay, photodiode, it will work on the principle of light. Okay, so light, the more the light it is illuminated, the more the current flow will be there. Okay, and mainly this is used in communication. Okay, optical fibers and communication, it is very useful. Okay, fine. Now we'll go with the next special type of transistor diode. It is light emitting diode, which is also called in short as LED. Okay, so we all are very familiar with this LEDs. What it will do, it will emit the light. Okay, so you might be having your LED TVs, LED bulbs, or even your mobile phone consists of LED. Okay, so let us learn how this LED will be. So coming to the symbol LED, as the name indicates, it is light emitting diode. Okay, so it is again the PN junction diode only, but only thing is it will eliminate the light here. Okay, it will give the light, whereas a photodiode, it will take the light, and based on the light, the current will be current will be flowing. But here in the light emitting diode, what happens, the diode itself will emit the light. Okay, again this is P and this is N. So here, since it is emitting the light, the arrows are outside like this. Okay, so this is again the special kind of PN junction diode. But here the difference is these LEDs, these diodes are made with different materials. Okay, so like gallium arsenide, gallium phosphide, like this, different materials are used. Based on different materials will emit different colors of light. Like all VIBGYOR colors will be eliminated. We have all VIBGYOR colors LEDs available. And so based on the material you are using, the color, that particular color will be eliminated. Okay, so that is what the basic principle, and why it is emitting light is because of these materials which are used. Otherwise, what is the difference between this diode and the normal diode? In the normal diode, if you take the normal PN junction diode, when it is forward biased, okay, forward biased in the sense P should be connected to positive and N is connected to negative. What happens here also, this is your P and this is your N. P is connected. One second, ma'am. One second, I've got call from HOD. Hello, ma'am. Okay, I'm sorry for the interruption once again. In the normal PN junction diode, what happens when it is forward biased? P will forward biased in the sense P will be connected to positive and N will be connected to negative. So what happens here? I'll have more holes as the majority charge carriers, and here I'll have electrons as the majority charge carriers. And these are nothing but the here I'll have the depletion region, which will have negative ions this side and the positive ions this side. So what will happen here? This is connected to positive and this is connected to negative. So what will happen? The holes will be repelled by this positive terminal, and here the electrons will be repelled by this negative terminal. It means that from one location to the other location, the electrons are moving. Okay, and here what will happen when these are moving from one location to the other location? It will recombine with the other atoms. Okay, so what will happen here? The recombination is happening. Wherever hole is there, that hole will be occupied by this electron. Okay, so it is nothing but the recombination. Whenever this recombination is happening, this diode will emit that energy in the form of heat. Okay, so this is with the normal PN junction diode, which is made up of silicon or germanium. Okay, but here in this special type of diodes which are made with a different material, what happens here is whenever the recombination is happening, that energy will be released in the form of light. Okay, so that is the reason these diodes are capable to emit the light. This is what the principle of your LEDs, how this LED is these LEDs are able to emit the light is based on this principle. Whenever the recombination happens, okay, so I'll just take the recombination in the sense positive and negative holes and electrons will get combined. Whenever this this electrons combines with the holes, what happens? It will emit the light. Okay, so instead of heat, it will emit the energy in the form of light. So that's why it is capable to emit the light, and this light will depend on the material that is used. Okay, different materials will provide different colors. Okay, and this process of light emission in this PN junction diode is said to be the electroluminescence. Okay, so because it is illuminating the light, it is said to be the electroluminescence. Okay, so now I think it is clear for you, like when this diode will work, in which biased condition this diode will work. It is the forward biased. Okay, same as your PN junction diode when it is forward biased, but here in the PN junction diode, the whenever recombination happens, it will emit the energy in the form of heat. Okay, whereas in the LEDs it is forward biased only, but what will happen here is whenever the recombination happens, it will emit the light in the form, it will emit its energy in the form of light. Okay, so that is what the difference. So let me just give you the characteristics. So as I've already mentioned, it works in the forward when it is forward biased, VF, IF. Okay, here what is a principle? It will eliminate different lights. Okay, so like it may eliminate IR light, red, yellow, green, blue, different types of LEDs are available. So what this LEDs will do, it will emit light. Okay, so based on the material used, the lights will be illuminated. Okay, so if you just check the characteristics, it will be same as your normal PN junction diode only. Okay, so this might be for IR light, in the sense like for some particular material, this infrared light will be illuminated. So that for that the characteristics will be in this way. Or for the next one, like maybe red, it will be like this, or amber, yellow, green, then blue, white, like that. It varies. The light that is illuminated by the LEDs will vary based on the material it is used. Okay, so but one more thing here is if you take a normal PN junction diode, until knee voltage, very small current will flow, and after that the current will increase linearly. Here also the same principle, but here if the PN junction diode is made up of silicon, then the knee voltage was 0.7. If it is with if it is made with germanium, it was 0.3. Now here what happens? Since the PN junctions are made with different materials, the knee voltage will vary from 1.7 volts to 3.3 volts. 1.7 volts to 3.3 volts. Okay, knee voltage will vary from 1.7 volts to 3.3 volts. Okay, so the reason behind it is eliminating 1.7 volts to 3.3 volts is like it is made up of other materials. So it may range from anywhere between 1.7 to 1.3. Okay, and coming to the reverse biased, so same as your normal PN junction diode. So very small current will flow because of the minority charge carriers, and when it is reverse biased, until VBR, you will have very small current, and this is a maximum reverse current that it can flow, which is said to be the saturation current, and it should not be used in the breakdown region. If it goes to the breakdown region, the diode will be damaged. Okay, so these are the characteristics of your LED. Okay, hope this LED is clear to you. Is this LED clear to you? LED working and its principle, everything is clear?
Yeah.
Okay, so now what we'll do, we'll go with the next diode, which is nothing but a photocoupler. Okay, photocoupler. So in the photocoupler, what we'll do is coupler in the sense we'll just make two things work together. So what happens here, first of all let me draw the diagram, and then I will help you to understand that particular circuit. So let me just draw the circuit first. Okay, so here this is a photocoupler. If you just see this diode, this is nothing but your LED. Okay, LED. What it is doing? It is eliminating the light. And what is happening with this light? This light is falling on the photodiode. Okay, so whatever light is illuminated by this LED, that is falling on photodiode. So both are coupled. They are electrically coupled in the sense like other than this part, everything other part will be sealed. So this is how it is constructed. Okay, and see, as I've already mentioned, the photodiode will work when it is reverse biased. Okay, and when it comes to the one second now. Sorry for the disturbance once again. So what will happen here? So this is my this is a photodiode which has to be reverse biased. Sorry, this is the LED which has to be forward biased. LED will work when it is forward biased, and this is a photodiode. This is the photodiode that will work when it is reverse biased, and this is a LED. Okay, so what will happen, the light that will be emitted by this LED will fall on this photodiode, and when it is reverse biased, the current through the circuit will flow. Okay, so if you just observe, first of all let us see how LED is biased. Okay, so this is my LED, how it is biased. See, this is my P and this is my N. P is connected to positive and N is connected to negative. So it here this voltage, whatever VS1 I am supplying, it will ensure that the LED is forward biased. Since it is forward biased, the light will fall on this. Okay, and here if you observe the connections related to the photodiode, this is my P and this is my N. P is connected to negative and N is connected to positive. This ensures that the photodiode is reverse biased. Okay, and here what we are doing, here I am giving the input, and at this point, at this voltage, at this resistor I will be taking the output. Okay, at this resistor I will be taking the output. Okay, and you know that here the current will flow, since it is forward bias, the current flow will be in this direction, and since this is reverse bias, the current flow will be in this direction. Okay, the current flow will be in this direction. Okay, so current electrons will move from N to P, so the current will flow. Electrons will flow from P to N, so the current flow will be in the opposite direction because it is reverse biased. Okay, and since it is forward biased, the electrons will flow from N to P, so the current will be in the opposite direction. So the current direction is in this way here, and the current direction is in this way here. So now here what I need to do, I need to find the voltage, output voltage across the R2. Okay, so current is flowing in this direction, so this is positive and this is negative. Let me name this as V0. I need to find V0 output voltage. Okay, so how will you find V0 output voltage? We need to first check whether light is illuminated or not. So for a specific power supply, this diode will be forward bias, so the current will start flowing in this direction. Okay, so since it is forward bias, current will flow. Okay, until 1.7 or anything in between 1.7 to 3.3 volts, very small current will flow, and after that it will increase linearly. Okay, so here since this LED is forward biased, it will emit the light, so the light is emitted in this way. Okay, since the light is emitted, this the photodiode is getting the photons that is falling. Okay, so because of this photons, what happens, and it is, if you observe, the photodiode is also reverse biased. So what happens, the current will start flowing. Okay, and the current direction will be in this way. So since the current is flowing, you'll have V0. Okay, so if you want to increase the V0 output voltage V0, what you need to do, you need to increase this. As you increase Vs, the LED will emit more light. The LED will emit more light. The more light is emitted, the V0 will be more. Okay, so that's how this is completely working. Okay, so let me just summarize once again. Okay, so here what I'm doing, I am using LED and a photodiode. Both are used in this particular circuit. So towards the input side, I have the LED. I have the LED which is illuminating the light. This is nothing but my LED. And towards the other side, output side, I have the photodiode. Okay, photodiode. So if there is no light emitted, in the sense if I'm not biasing this LED, then it will not illuminate the light. If there is no light illumination, then the output voltage will be equal to 0. Okay, now what we need to do, if we want to emit the light from the LED, you need to bias it. Okay, so you know that LED should be forward biased and photodiode should be reverse biased. So LED is forward biased by connecting P to positive terminal and N to negative terminal. So since it is forward biased, the current will start flowing through this. Okay, so the current is flowing. So what it will do, the recombination will be happening in the LED. In the recombination of electrons and holes will be happening. So what happens, the LED will emit the light. So that light which is illuminated by the LED, that will fall on photodiode. And if you observe, the photodiode is reverse biased. Okay, because the photodiode is used in the reverse bias characteristics. Okay, so P is connected to negative and N is connected to positive. Okay, so here I was telling you when I was teaching you the photodiode, the dark current should be less. Okay, so this is what the reason, because if no light is falling on this, the voltage V0 should be equal to 0. So when this voltage V0 will be equal to 0, if there is no current flowing through the device, if no current is flowing in this device, then V0 will be equal to 0. Now as you increase Vs, the amount of light that is illuminated by the LED will be more light is falling on this, the V0 will be increased. Okay, so based on your input voltage, the output you are able to obtain. More the input voltage, more the output voltage, because more the light that is illuminated by the more the light that is illuminated by the LED, and that more light will fall on the photodiode. More the light is falling, the output voltage V0 will increase. Why? Because the current will increase. As the current is increasing, V0 will also increase. So this is how it works. And even if you ask me the applications, it is used in communications mainly. Okay, whenever you are using the optical fibers, okay, there you'll be using both the LED and also the photodiode. Okay, LED will be will be connected between the input side and the output side. So this photocoupler is used mainly in the communication. Okay, so these are the some of the special type of diodes. Okay, so hope all of you understood this photodiode and LED. Have you all understood the photodiode and LED?
Yes, ma'am.
Okay. Yes, ma'am. Okay. So we have one last topic. So coming to the knowledge levels, yesterday you people could not answer that. So in this module, we'll be studying rectifiers, different types of diodes, voltage regulators and all. Okay, and if we are analyzing the circuit, if we are just learning the basics, then you need to remember, understand, then analyze and then apply. Okay, so that's how it goes. So if we are doing the problem, we are doing the analysis. If we are like learning some concepts, it is like we are applying whatever we are understanding. Okay, so now let me go to the, I'll just give the introduction of the next topic. Okay, maybe I'll not be able to finish it completely. I'll just give you the next topic. So voltage regulators, this we have already studied, but here specifically I will explain you. Okay, voltage regulator. Okay, so voltage regulator, you already know what the voltage regulator will do. Okay, voltage regulator, what it will do, if you just take the Zener diode. Okay, Zener diode, based on the circuit connection, we have just connected it something like this. Okay, something like this we have connected. So whatever, so this is the load, and this is RS, and here I am providing some input which should be greater than the Zener breakdown voltage. So if and one more condition is the current through the Zener diode should be in between IZ minimum and IZ maximum. This is what I was saying you. Okay, so if the current through the Zener diode is in between IZ minimum to IZ maximum, then whatever and Vs, the input voltage, supply voltage, whatever supply voltage you are giving, if that is greater than the Zener breakdown voltage, okay, Zener breakdown voltage, it will be obtained from the data sheet. Okay, so if this Vs is greater than Vz, and if the current through that is in between Iz minimum and Iz maximum, then the voltage across the load VL will also be equal to Vz. Okay, VL also will be equal to Vz. Okay, so this is how the voltage regulator will work. Okay, so here I have just said that based on this Zener diode, the output voltage will be maintained to that level. Okay, if this Zener voltage, Zener breakdown voltage is 6 volts, then VL will also be equal to 6 volts, or 20 volts, this also will be equal to 20 volts, like that it goes. Okay, so these are the voltage regulators. So here if you just recall, okay, recall in the what is that, filters, rectifiers. Okay, so what we did with the rectifiers, first we have taken the rectifier. So rectifier is a circuit which will convert AC to DC. Okay, so first we'll convert the we'll connect the rectifier to the input supply, which is nothing but the AC signal. Okay, here I'll give the AC signal. So the output of the rectifier was not pure AC, but it was pulsating AC, pulsating DC. Okay, so this is the rectifier output. Then what we are doing, we are giving this rectified output to filter. Okay, if you just recall, we have used C filter. Okay, so then C filter, what was the output across the load? Across the load we were getting like this. Yes, this is what the output we were getting in the after connecting filter to the rectifier. So here if you observe, still it is not the pure DC, it is the pulsating DC itself. So now what we'll do here, if you observe, there are changes. Okay, so the current through the capacitor is changing, or the voltage across the capacitor is changing. So here it is changing, right? So this change, I need to make this change to pure DC signal. At the output, I need to get pure DC signal. So what I'll do, this filtered output, I'll give it to the voltage regulator. Voltage regulator. Okay, so when I give this filtered output to the voltage regulator, what it will do, even though there are changes in the input here as I mentioned, it should be greater than Vz. Okay, even though I am changing this Vs, okay, the voltage across the Zener diode will be kept constant. That's how I am getting the constant DC voltage. Okay, so that is what, because even if you observe here, as I am changing Vs, the current through the device will increase. Okay, so current through the device, Is will increase. Is is increasing, even Iz will be increasing. Okay, so Iz is in between Iz minimum and Iz maximum. Okay, so this should be maintained. Okay, so even though the current through the device is varying, or even though the input voltage is varying, what will happen, this voltage regulator, what it will do, it will provide you the constant output voltage. That is nothing but the DC output voltage. Okay, so here this complete setup, rectifier, filter and voltage regulator, this complete setup will convert your AC signal to the DC signal. Okay, so this is what the concept of your voltage regulator. Okay, hope this is clear to you. I have just given you the very basic introduction. Still I have not gone to the actually what is supposed to be done here. Okay, I have just explained you how this voltage regulator is working. Okay, so this is related to the voltage regulator. So here I'm just saying that this voltage regulator, it is stabilizing the voltage. In the sense, it is providing some constant output DC voltage. Okay, but how much DC voltage it has to provide? Okay, so that depends on on the ICs that you are using. Okay, based on the IC you are using, my output DC output voltage will be decided. Okay, so let me just give you the different voltage regulators. We have different types of voltage regulators. They have different types of voltage regulators. Okay, so they are, first one is fixed voltage regulators. Second one is adjustable voltage regulators. And the third one is switching regulators. Switching voltage regulators. So these are the three types of voltage regulators we have: fixed voltage regulator, adjustable voltage regulator, switching voltage regulator. See, first one, the fixed voltage regulators. It means that, see here I have told you that this voltage regulator, what it will do, it will stabilize the output DC. Okay, it will provide you some DC output. So in the fixed voltage regulators, what it will do, it will that particular IC. So it is, voltage regulators are again ICs only. So what this IC will do, it will provide you some constant DC voltage. In the sense, like if I say that it is 7805, the IC number is 7805, then it will provide 5 volts. Okay, or 7905, then it will provide you minus 5 volts. Like that it goes. Okay, 7808, so it will provide you 8 volts. Like that, different ICs will provide you fixed output voltage. Okay, so that is the reason these voltage regulators are said to be the fixed voltage regulators. So fixed voltage regulators means it will provide you some constant output voltage. Okay, some constant output voltage. That is what your fixed voltage regulators. So again, as I mentioned, you have positive voltage regulators and negative voltage regulators. Negative voltage regulators. Positive voltage regulators, in the sense, it will give plus 5 volts or plus 9 volts, like that. Okay, positive voltages it will give. Negative voltage regulators, in the sense, it will give minus 5 volts, minus 9 volts, minus 12 volts, like that. Like that it will provide you the output. Okay, so in the fixed voltage regulators, again you have two types: positive fixed voltage regulators, negative fixed voltage regulators. Positive fixed voltage regulators means it will provide you the output voltage will be some constant positive voltage. Negative voltage regulators, in the sense, it will provide constant negative voltages. Okay, that is what fixed voltage regulators. So in our syllabus we'll study fixed voltage regulators only, that too specifically 78XX series. In the sense, positive voltage regulators are nothing but its IC number starts with 78, and XX can be either 05 or 08 or 12, like that. So this, whatever this last digits are there, it will specify how much constant voltage it will provide. So let me take 7812. So it means that it will provide you 12 volts constant output. 12 volts constant output. Or let me just take 7805. Okay, so this last two digit will tell you how much fixed voltage it will provide. So it is 5 volts plus 5 volts. 7808. So it will provide you 8 volts. Okay, 7824. So it will provide you output 24 volts. Okay, so that is what it means. So in general, we can write it as 78XX. Okay, in the same way, negative voltage regulators, but anyway, we'll be studying 78XX voltage regulators only, which will provide you the constant positive voltages. And coming to the negative fixed voltage regulators, it is 79XX. Okay, 79XX. 79XX, in the sense, 79, if the IC number starts with 79, it indicates that it is negative voltage regulators. So as I was mentioning, 7905 indicates it will provide you constant minus 5 volts, okay, or 7908, so minus 8 volts. 7910 will provide you minus 10 volts. 7915 minus 15 volts, okay, like that. 7920 minus 20 volts, like that. Okay, so this first two numbers, if you see it is 79, then it indicates that these are negative voltage, negative fixed voltage regulators. Okay, but anyway we will concentrate on 78xx. Okay, 78xx, this xx will tell you how much voltage, output voltage it will provide you. Okay, either 5 volts, 6 volts, 7 volts, 8 volts, 10 volts, 12 volts. Like it is not like all the ICs with all the voltage levels are available. I'm just giving you some examples: 7, 6, 8, 10, 12, 15, 20, like that it goes. 20, 24, 18. Okay, like that it goes. So this last xx, based on this last xx value, you'll be able to identify how much constant output voltage you'll be getting. Okay, so this is related to the fixed voltage regulators. Coming to the adjustable voltage regulators, see what this voltage regulators will do in the sense, like it may provide in the range of 5 volts to 12 volts, so you can adjust. Okay, so this voltage regulator, again it is nothing but the IC only. So what this IC will do, it may give you the rating will be given like 5 volts to 12 volts. It means that if you want to set 8 volts, 8 volts also you can set by adjusting the circuit parameters. You will be able to get 8 volts, or you will be able to get 10 volts, or whatever it might be, in between 5 volts to 12 volts. How much ever voltage you want to fix, you will be able to fix. Those are nothing but your adjustable voltage regulators. Coming to the switching voltage regulators. So here in the switching voltage regulators, what it will do, it will take the DC signal, it will first convert it to AC signal and then convert it back to the DC signal. Okay, so that is how it will happen here. So that is the reason the name switching comes into the picture. Okay, so for our syllabus, as we have fixed voltage regulator, that 278xx, will be studying in detail about this 78xx, 78xx voltage regulator. Okay, so hope you people understood this voltage regulator. Is this diagram clear to you? This diagram is clear to you? How it is converting rectifier output to filter output to the voltage regulator is given, then how it is converting into DC. Okay, so here based on this Vs value, Vs, see here the input to this is nothing but variable voltage. Okay, so variable voltage is given to the voltage regulator. So when you are providing the variable voltage, if that voltage is greater than Vz, still the output across this Zener diode will be constant. Okay, but whatever maximum voltage you are getting here out of the filter, that you need to take care that it is greater than this Zener diode breakdown voltage. Okay, if that is satisfied, then this voltage regulator will provide you some constant output voltage. Okay, hope this is clear to all of you.
Yes.
Hope anybody have got any doubts, please let me know. In the next class, we will specifically see the circuit for LM. Generally, it will the IC name is given as LM78xx. Okay, this is the IC name. This will be fixed, and this based on this will be able to identify which voltage regulator it is. It means that whether it is providing 5 volts or 7 or 8 volts or 12 volts, like that we will be able to identify. So in the tomorrow's class, I'll explain you the circuit because I have the circuit for this. So right now if I just start, I'll not be able to finish it in the stipulated time. So what I'll do, I'll teach you this LM78xx tomorrow, and after that I will. This is the last topic. Okay, so after this I will start module 3. I'll leave module 2, I'll start module 3, and in module 3 we'll be studying about op amps and its applications. Okay, so let me just finish module 3 and then go back to module 2. Okay. Anybody have got any doubts until here? Please let me know. LM78XX I'll explain you tomorrow.
No doubt.
Anybody? Others?
No doubts, ma'am.
Everything is clear. So tomorrow's
Yes,
class, after finishing this topic, I'll start module 3. Okay, fine. Or else if you want me to just revise as a crash course, I'll do that. Anybody want me to revise the complete module? I'll do that. The choice is
ma'am,
given
after third module.
after third module.
Yes, ma'am.
After third module, I should come back to first and revise. That's what you mean to say, Yashwant?
Yes, ma'am.
Okay, ma'am. Okay, no problem. Okay, fine. That's all for now. If anybody has got any additional doubts until this point, you can ask me. Otherwise, the class is done for the day.
Thank you, ma'am.
Thank you, ma'am.
No doubts, ma'am. Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Aditya Sharma.